Okay, this is an example of a question which involves exponential modelling. I'm not sure if this is actually a very good equation for a cup of hot water that's being left to cool. So apologies if it's not very realistic. It's temperature T at time T, lowercase t is given using the following model. We can look at what is the temperature initially. So you've done bits of modelling already, and like in mechanics, initially is what's the temperature at the beginning. So you just set T equals to 0, and then the temperature will equal 20 plus 75 e to the power 0. Any number apart from 0 to the power 0 is 1. And 20 plus 75 is 95. Temperature after 1 minute. So I'm going to let T equal 1 because T is defined in terms of minutes. Just check your units match, because sometimes they try to trick you out with stuff like that. So it's 20 plus 75 times e to the negative 0.1. So you can chuck that into your calculators. If you haven't found the button for e to the x, it's there above the natural logarithm button. We'll do natural logarithms in a bit. And so you can just plug that in. So 20 plus 75 times e to the negative 0.1 gives you 87.9 degrees C. Doesn't feel too ridiculous. What is the long-term prediction of the temperature? So for the long-term predictions, you need to let T approach infinity. And as T approaches infinity, let's build this up. E to the negative 0.1 T. Remember, that's the same as 1 over e to the 0.1 T. So as T approaches infinity, this is approaching 0. And so when you multiply by 75, that will also approach 0, because it's just times it by 75. But when you add 20 on, so when you add 20 onto this bit here, it will add 20 onto that 0. It doesn't have any t's in it, so it's not affected by t. And so this approaches 20. And then what does your answer to B represent? So you might be asked to kind of think a little bit out of the box, but not too much. So if the cup of hot water is cooling to 20 degrees C, it doesn't get any lower than 20 degrees C. That would be the temperature of the surrounding air. Or room temperature would be okay there, I think. So temperature of surrounding environment. Feels like about the right thing to say. And then sketching the graph. If you're quite comfortable with your curve sketching, you could answer some of these questions from a sketch as well. So that's the other option. So for this one, you can use what you've done, or the way we've been sketching these. So when T is 0, 20 plus 75 is 95. And that's the initial temperature of the drink. And if you wanted to just sketch T equals 75 e to the negative 0.1 T, that's decay because it's a negative power. And so it'll be coming down like this from 75. And then the plus 20 moves this graph up by 20. So the asymptote is going to come across at 20. But you sort of know that because that's what the temperature's approaching as T approaches infinity. So you can do just how we've done the curve sketching earlier in the lesson, but you can also use the stuff that you found already. So there's that initial temperature of the drink at 95 and it's cooling to 20. I wanted to just go over one other sketch with you to make sure you're okay with it. And again, it's if you've got a handle on your transformations, it really does make life a lot easier. So I wanted to just look at sketching y equals 20 minus 5e to the 0.1x. And so, building this up, y equals 5e to the 0.1x is exponential growth, because we're positive here, going through 5. You need to sort of follow BIDMAS now, so I need to do the timesing by -1 bit next. And that's going to give me a reflection in the x-axis, because that's minus f of x. So that's going to be coming around like that. So -5. And then this is adding 20 on. So you could actually write, it doesn't tend to get written like this, but you could write this if you wanted to, that way round. So add 20 moves that asymptote up by 20. And it will move the y-intercept up by 20. So we're going to have an asymptote at 20. Y-axis intercept at 15. And then the curve coming down like so. So yeah, transformations are very useful when you're sketching things like this. You could kind of think about what happens as x approaches positive, negative infinity within the equation of this graph. But do think about using transformations to sketch. Okay, so that's that sketch.